Do helicopters really fly? Leonardo da Vinci came up with an idea. It never got off the ground. Tom Clancy says, yeah, they get in the air, but they don't fly. At least he doesn't mention it. But I can tell you they do fly. I've got quite a few hours in both those types of helicopters. Before I really dig into how a helicopter works, I want to talk a little bit about aerodynamics and how airflow affects how a helicopter, or airplane for that matter, flies. I've got a piece of paper sitting across two books with a little tunnel through there. Right now, the air pressure pushing up on the paper from below is the same as the air pressure pushing down on it from above. I'm going to blow through that little tunnel. How many people think the paper is going to fly off the books? Uh-oh, okay. Had me worried there for a minute. Everybody knew the answer. All right, watch what happens here as I blow through this tunnel. All right, that's Bernoulli's principle. It says that as the speed of the air increases, the pressure that it exerts decreases. So now the pressure pushing up on the paper was less than the pressure pushing down, and that's why the paper went down like that. Right, that's one of the main reasons an airfoil or a wing works. You have this wing coming into the air's got to go around it. Because the air has to go a longer distance across the top than it does the bottom, it's got to go faster along the top. And what did we see here? The pressure decreases. So the air pressure pushing up on the bottom of the wing is greater than that pushing down on it. So what's that give you? That gives you lift. Right, that's one reason that a wing works. There's another component of that. How many of you have gone down the road at 60 miles an hour and you stick your hand out the window and then raise your hand? What, you know, it's kind of rough on shoulders. Right. Same thing here. That's also part of what causes lift. And one other thing I wanted to point out, there's something called angle of attack, or in terms of helicopters, we're usually talking about the pitch of a blade, how much of an angle is it making. So that's this angle right here between the horizontal and what's called the chord of an airfoil. As a general rule, the steeper the angle of attack, or the greater the pitch, the more lift you'll have, up to a certain point. Get too far and you stall and everything falls out of the sky. That's a problem. But up to a certain point, that's what you have. Now, on a helicopter or airplane, get rid of the rear rotor for now. Airplane, you have to get on the runway, start down the runway. Once you get enough airflow over the wing, lift is enough, and you take off. Helicopters, we don't need to do that. All we have to do is spin the blades like that. And what's happening? Instead of having to drive this thing through the air to get that air flowing over the wing, you're moving the wing into the air by rotating. So now we've got an idea. We've got lift on the blades, but how are we going to control that lift? That's the secret. This is a diagram of a helicopter. Let's say it's the front blades on this one. You as a pilot would be sitting up here in front, moving your controls. You're stationary is in reference to that body of the aircraft. The blades are going around. How are you going to change the pitch of those blades? The secret is what we call the swash plate. How many of you are familiar with a Lazy Susan? All right. The swash plate really is nothing more than a glorified Lazy Susan. This wood sits on the outer ring, you're able to spin it. The lower ring is fixed on the table. This is the fixed part of your swash plate. There are those bearings. The upper part spins the same rate as the rotor head. So now what we have in here are these control arms from the upper swash plate to the blade. It would be to an edge of this sort of the blade. There'd be a little arm sticking out here and a rod coming up to it. So as this rod goes up and down, it's going to cause the pitch of the blade to change. Now what happens? Let's say we want to just lift straight up. The pilot's going to grab the collective, and I'll tell you why it's called the collective here shortly. Each one of these lower rods will move up the same amount. This whole swash plate then will move up a little bit. And each rod from the upper swash plate to the blade will move the same amount. So what's going to happen to the pitch on the blades? You're going to get the same amount of pitch on each blade, which means you're going to have the same amount of lift. And the helicopter will just go straight up. Now, we're in the air. How are we going to get that thing moving forward? The other control here that gets a little trickier, I'm sorry, back up for a sec. So, when I said we pull on the collective, collectively we're moving everything equally. As the blades go around, the pitch on the blade stays the same. Now, if we want to move forward or sideways, we need to use what we call the cyclic. And that's the stick that you see in most airplanes. Now, if this is the forward direction, and I want to go forward, what I'm going to do is somehow get the lift on the back end of the aircraft or the helicopter greater than the lift on the front of the helicopter. So that as you take off, you're in the air, you want to go forward, you're going to try to tilt it down this way. Now your lift is sort of pointing in this direction, so it's going to let you go up that way. Now how do we do that? Again, that's with the cyclic. So if I push forward, this aft control tube is going to go up, the forward one goes down. Now if this were the swash plate sitting here, it's going to tip like this. So as the rotor goes around, what's going to happen to the distance, or this link, this fixed control tube as it comes around? It's going to be pushed up as it comes around here. It comes up, and as it keeps rotating, it goes back down. So cyclically, it's going up and down. Now, as it comes up, it's doing what? What's happening to the pitch on this back blade? It's going to increase, get more lift on the back. As this blade comes around to the front, again, now the tube is down, what's going to happen to the amount of lift on that front blade? It's decreasing. So you have more lift in back, less in front, wants to tip you this way. That's what you will need to do in order to get some forward motion. Now, how do we go sideways? Exactly the same idea. Instead of that rear tube getting extended by tipping your swash plate this way, now we're going to tip it to the side by taking that control and moving it to the side. So if I want to go to the left, I'm going to roll it this way and go this direction. I'm going to increase the lift on this side, decrease the lift over here, so the helicopter tips this way, and away you go. Rearward, Now we're going to increase the pitch on the front, decrease it in back, and you go backwards. Try that in a fixed-wing aircraft. All right, so now we've got most of the axes taken care of. We still have what we call yaw, left and right. If you would, if you can, get up out of your seat just a little bit. Take the weight off your seat, grab the table, and try to shove it to the right. What direction is your behind going? The opposite direction. All right. Same thing happens here. As the aircraft tries to spin the blade this direction, the body of the aircraft wants to go in the opposite direction. Now, is that good if you happen to be in the air?
No.
No. So there we have, on some aircraft we have, oops, I'm sorry, the tail rotor right here. So as the aircraft or the tail tries to swing this way because of the torque, you have a force going that way that counteracts it. This type of helicopter, instead of a tail rotor, we have a second rotor up here. It spins in the opposite direction, which counters it, that torque. So a couple different ways that you can counter that torque.
Question, can you have them one on top
Yeah,
of
the
another?
Russians have quite a few of those.
That's what I was
Exactly.
wondering.
Yeah.
You don't.
Yeah, they're basically, they sit like this. One goes one direction, one goes the other. Where?
So how does the tail rotorless helicopter works?
I'm sorry, the what?
A helicopter
rotor?
without tail rotor, because I saw it some.
Okay, it's exactly, works the same way. It's got a small swash plate, so you can vary the pitch on those blades also.
I'm sorry. I saw some helicopter without a tail rotor. So how does they
There are
work?
different kinds. It could be counter-rotating like this. You could have air jets back there.
Okay.
There are different ways to do it. All right, hopefully you've gotten an idea. I've now got an hankering for getting back in the air. If you guys really want a thrill ride, take a lesson and try to hover. Toastmaster.